Could an advanced civilization have thrived on Earth millions of years ago and disappeared without leaving a trace? Two NASA scientists think the answer might be yes, and their reasoning will completely change how you think about our planet's history and humanity's future. This is the Silurian hypothesis, and it's one of the most mind-bending thought experiments in modern science. Here's what blew my mind when I first learned about this. Human industrial civilization is only 300 years old. Earth is 4.5 billion years old. If our entire civilization lasted 10,000 years and vanished, it would be 0.00002% of Earth's history. That's like finding one page in a library with 4.5 million books. But here's the kicker. We find T-Rex fossils from 65 million years ago, so surely we'd find ancient computers or cities, right? Wrong. And the reason why reveals something terrifying about how easily entire civilizations can vanish. The Silurian hypothesis isn't about ancient aliens or conspiracy theories. It was proposed in 2018 by NASA climate scientist Gavin Schmidt and astrophysicist Adam Frank. They asked a simple but profound question. If an industrial civilization existed on Earth millions of years ago, would we actually detect it today? Their answer shocked the scientific community. Think about this. We have thousands of T-Rex teeth, but fewer than 50 complete skeletons. These were massive animals with dense bones, living for millions of years. Yet fossilization is incredibly rare. Now imagine fossilizing a smartphone. The materials would corrode, decay, or get recycled by geological processes long before fossilization could occur. Even massive structures like the Empire State Building are tiny compared to mountains that get completely erased by plate tectonics. Pause for a moment and consider. If humans vanished today, what would survive in 10 million years? Your house? Your car? The Golden Gate Bridge? Plate tectonics recycles the ocean floor every 200 million years. Continental drift reshapes entire landscapes. Most of our civilization would simply disappear. But Schmidt and Frank realized something crucial. While the artifacts vanish, the chemical fingerprints remain. Every industrial civilization must leave specific signatures in the geological record, like a chemical crime scene that persists for millions of years. Energy consumption. When we burn fossil fuels, we release carbon that's been locked underground for millions of years. This ancient carbon has a distinctive isotopic fingerprint that shows up in atmospheric records and gets preserved in ice cores and sediment layers. Industrial pollution. We create synthetic compounds and unusual metal concentrations that don't exist naturally. These get deposited in geological layers, creating permanent records. Climate modification. Large-scale energy use changes atmospheric chemistry. These changes get locked into the geological record. Right now, we're creating what future geologists will call the Anthropocene, a clear spike in atmospheric CO2, unusual metals, and even microscopic plastic particles starting around 1800. But here's the question that changes everything. Could similar spikes already exist in Earth's ancient rock layers? When the scientists looked at deep time with this new perspective, they found something unsettling. There are periods in Earth's history that show rapid atmospheric changes and unusual chemical signatures. The most dramatic, the Paleocene-Eocene Thermal Maximum, 56 million years ago. Global temperatures spiked 5 to 8 degrees in just a few thousand years. The carbon isotope ratios look remarkably similar to massive fossil fuel burning. The Permian-Triassic extinction, 252 million years ago, shows similar patterns. Rapid atmospheric changes that could theoretically result from industrial activity. Now, scientists have explanations for these events. Massive volcanic eruptions, methane releases, asteroid impacts. But here's what makes this hypothesis so unsettling. We might not be able to tell the difference between natural catastrophes and industrial collapse. Would aliens studying Earth a million years from now be able to tell we ever existed? The answer is genuinely uncertain. Here's where this gets truly mind-bending. The detailed geological record we can access goes back about 500 million years. But complex life has existed for over 3 billion years. That's a 2.5 billion year window where advanced civilizations could have existed, and we might have no way to detect them. Multiple ancient civilizations could be completely invisible to us, their evidence buried too deep or erased entirely. Think about the implications. We could be the latest in a long line of Earth civilizations, each believing they were the first, each leaving traces that the next civilization might never find. This completely transforms our understanding of intelligence in the universe. The Silurian hypothesis offers a chilling explanation for why we haven't found aliens. Maybe the galaxy is full of dead civilizations. Most SETI searches look for active civilizations, radio signals, megastructures. But what if most civilizations went extinct millions of years ago? What if technological intelligence is common but brief? Consider this timeline. Complex life took 3 billion years to evolve intelligence on Earth. But industrial civilization might last only centuries before facing existential challenges: climate change, resource depletion, nuclear war. If this pattern repeats across the galaxy, space could be littered with planets that briefly hosted intelligence before returning to purely biological evolution. We're not looking for civilizations, we're looking for graveyards. This adds emotional weight to our own situation. Every choice we make about sustainability, every decision about our planet's future, determines whether we join this hypothetical cosmic graveyard or become something unprecedented. A civilization that survives its technological adolescence. The universe might be watching to see which path we choose. So are there actually hidden civilizations in Earth's geological record? The honest answer: we don't know, and we might never know for certain. Recent research focuses on detecting technosignatures, unusual combinations of isotopes, microscopic artifacts from advanced materials, subtle patterns in extinction events. But we face fundamental limitations. Scientists estimate that if ancient industrial civilizations existed, they would need to have been relatively brief, thousands of years, small compared to geological processes, and unlucky enough to leave signatures that were later buried beyond detection. We're essentially solving a mystery where plate tectonics, erosion, and geological recycling have destroyed most of the evidence. It's like being a detective investigating a crime scene that's been through a blender. But the search continues because the implications are profound. Whether or not ancient civilizations existed on Earth, we know our civilization is creating signatures that will persist for millions of years. Future species will see clear evidence that intelligence once arose here. The question is, what story will those signatures tell? Will they record a civilization that learned sustainable technology and spread throughout the galaxy? Or will they show a brief industrial spike, followed by collapse? Another cautionary tale buried in deep time? The Silurian hypothesis forces us to confront our cosmic fragility. Intelligence might be common in the universe, but lasting intelligence could be extraordinarily rare. We might be part of a galaxy-wide pattern of civilizations that briefly transform their worlds before vanishing. But here's the hopeful possibility. By understanding this pattern, we might be the first civilization to break it. So what do you think? Could Earth have hosted forgotten civilizations millions of years before us? Are we alone in time, or the latest chapter in an ancient story of intelligence? Drop your theory in the comments, and if this blew your mind like it did mine, hit subscribe for more deep dives into the mysteries that could reshape how we see ourselves and our place in the cosmos. Because in a universe this vast and ancient, we might be far less alone and far more temporary than we ever imagined.